Morning everyone, and welcome to the session led by Working Group 3 on field and lab methods. We've got some great talks lined up on the programme, which are going to really showcase the depth and range of work that's been taking place over the last few years. But we wanted to start with a bit of an overview of what we've achieved as a working group. So there have been two main streams to Working Group 3. The first is building capacity for DNA-based monitoring through knowledge sharing and training. And the second is building consensus through workshops, experiments and ring tests. So I'm going to give you a brief overview of what we've achieved in building both capacity and consensus, starting off with capacity. So one of the most effective tools that we've had at our disposal has been the short-term scientific missions, or STSMs, which fund knowledge exchange and collaboration visits between institutions in different countries. So in Working Group 3, 22 STSMs have been completed with knowledge flowing to and from 21 different countries. These have covered a wide range of different species groups and protocol elements and have led to numerous research papers and ongoing collaborations. We've also run training courses with a real focus on enabling participation by scientists in ITC countries, which tend to have less research resource. So this was a training course in Bucharest in October 2018, which saw 20 participants from 12 different countries gain experience in both sampling and analysis of eDNA, and that was led by David Halfmartin, Emre, Keskin and others. And meanwhile, there's been a really active diatom group, which has run 4 different training schools between 2018 and 2020, each hosting around 25 participants, and again covering both field and lab methods for diatom assessment. And the plan had really been to increase the focus on training courses and capacity building in the final year of the DNAquanet programme. But unfortunately, like so many other things, this was thwarted by COVID, and so we haven't been able to run as many as we'd hoped. But we have been able to do a lot of work on consensus building. Now, taking on leadership of this working group was pretty daunting for us. There were a couple of hundred scientists signed up from the get-go. And when we sent out an early survey when we first started, our fears were confirmed. There were an even greater number of protocol variations. So our challenge was how to make progress in building consensus without just spending 4 years arguing with each other. So we started by throwing out the idea that there's one ultimate protocol to rule them all, and approached it instead with the acknowledgement that there's probably several different perfectly valid ways of doing each step of every analysis. But the answer is not to give up on consensus building and standardization, because this is crucial as the methods move out of the research world and into widespread application. So we're moving from a situation where one knowledgeable researcher or research group has got full oversight of the whole sampling and analysis process, including interpretation of results, to a situation where you might have a contractor collect the samples, a commercial lab analyse them, maybe somebody else does the bioinformatics and the data analysis, and then eventually the end user has to use the data to inform decision making. And sometimes those decisions are really expensive. So we need to be able to put in place systems and frameworks that enable decision makers to trust results and to interpret them correctly. So that's what we're talking about when it comes to standardization. And when we frame it like that, we found there was actually much more consensus than it originally appeared. So we set out trying to answer the questions that were being asked by the end users. They're faced with a really daunting array of methods, and that can be very off-putting and can lead quite quickly to the conclusion that this technology just isn't ready for use in the real world yet, when actually we know it can already provide so much valuable information that can't be obtained using conventional monitoring methods. So how can we deal with that? How should we standardize methods while still allowing for a fast pace of development and innovation? Well, we can't claim to have come up with all the answers, but we've definitely taken some useful steps in the right direction. So our consensus building activities have generated 4 different types of outputs. We've made tools to help guide interpretation of results. We've taken the first steps to creating formal SEN standards that set out the core principles of certain steps in the analysis process. We've undertaken methods comparisons and ring tests to start to understand how consistent the results can be when samples are processed in different labs and with different methodological choices. And we've produced best practice guidelines in various formats. So we'll start off with the methods comparisons and ring tests. There are 2 ring test projects underway at the moment. Both of them have been a little delayed by COVID. One is for diatoms, which is focusing on DNA extraction and PCR steps, and we'll hear more about that in a talk later today. And there's one on benthic macroinvertebrates, starting from a workshop back in Porto in 2018, which focuses on the same steps, so the DNA extraction and the PCR, and also incorporates a comparison of different DNA capture methods. So in this case, extracting DNA from homogenized invertebrates and also from the fixative solution that they were stored in. So both these tests arose from DNAquanet workshops, the macroinvertebrate one at the University of Porto in Portugal and the diatom one at the Cyprus University of Technology in Limassol. Now the point of a ring test is to see whether different labs can get the same results when they apply the same predefined protocol. For fish, we did something a bit different, taking advantage of a fish eDNA conference at the University of Hull in the UK. So this happened in the summer of 2019, and we knew that there were going to be fish eDNA metabarcoding experts coming from all over the world. So we asked them to bring along some of their usual sampling equipment. And one morning we went out and collected 100 litres of water from the local river and put it in this pool at the conference centre. So people during lunchtime brought their sampling equipment along and collected samples using whatever they normally would. And preserved them in whatever way they preferred, and took them back to their labs and ran a fish eDNA metabarcoding analysis, each lab following their own protocol and workflow. So we didn't specify anything or try to control for anything. Our real aim was to see if everybody takes these samples independently and just does them however they normally would, how similar are the results. So of course there was loads of variation with different choices being made at almost every step. And yet the results, especially for the 7 most abundant species, were virtually identical, both in terms of the species composition and also the relative read counts. So in this case, we start to show that results can be surprisingly robust to methodological variations when the protocols have been well optimized for the choices that have been made. And all of the labs that are featured here are labs that are very experienced in doing fish eDNA metabarcoding, so they're each running a well-optimized protocol, even if the details of the protocols vary. So moving on to the tools we've built, the most notable of these is the validation scale. This was a product of a workshop in Innsbruck in 2018, and it basically provides a framework for determining the extent to which a targeted single species assay, so a qPCR or ddPCR assay, has been validated, and for interpreting the results that are obtained from assays at each level on the scale. So I'm not going to go into more details about this here because Bettina will present it in one of the talks later in this session. We've also started working on formal standardization of DNA-based monitoring methods through CEN, which is the European standards body. And this will be covered in more detail in the Working Group 5 sessions. But just to give you a quick overview of what we've done. So the diatom group have already incorporated DNA-based methods into the CEN technical report on benthic diatom sampling from rivers and lakes. That was done back in 2018. And we've submitted a draft standard on aquatic eDNA capture. That's been submitted to CEN as a new work item proposal. And that was the result of a really fruitful collaborative exercise that was started in a workshop in Sarajevo in 2017 and then continued in Pech in 2018. And for me personally, this has been one of the most interesting exercises because when we all sat down initially, the starting point was that almost everyone did almost everything differently. So it seemed like a completely impossible task to embark on. And this was just with about sort of 20 people around the table from a range of different types of institutions and organisations. And the thing is that most of us, whether we're in academia or commercial environments, spend most of our time trying to differentiate ourselves from one another. But as soon as we turned the conversation around to ask not what do we do that's different, but what do all our different methods have in common? And we discovered that actually there was a really strong common core that ran through all of the different methods we used, which we could start building the standard around. And we had exactly the same experience at a workshop in Rome in 2019 when we started the same process for sediment sampling. So we had sort of one day of highlighting how we all do completely different things, and a second day then focusing on the fact that actually most of the basic principles were the same. So this hasn't made its way to a standard draft yet, but there's a manuscript in preparation led by Jan Pawlowski that sets out the recommendations that could develop into a new draft standard. So finally, the best practice guidelines aimed at practical applications of DNA-based monitoring. This guide to eDNA applications was published last year by Jan Pawlowski and Florian Altemat. It was aimed at biomonitoring in Switzerland, but of course it's got relevance far beyond that. And it's got really lovely illustrations and step-by-step instructions. And it's generally a great read if you're into this kind of thing. So I really recommend this. You can download it for free from. And meanwhile, a larger group has been working on another set of guidelines with a slightly different focus. So in the practical guide to DNA-based methods, which will be published as a Pensoft ebook, we synthesize collective knowledge and experience and set it in the context of the practical and logistical constraints that are faced by environmental managers. So we highlight the key decisions and trade-offs throughout the process and consider what might influence those decisions and how they in turn influence either the end result or other factors downstream in the workflow. And we also really describe the sort of quality control steps and things that are needed to provide assurance that results can be trusted and acted upon. So the idea is that this will be a useful tool both for people who are new to the field and choosing a methodological approach to use, so they can look at that whole workflow as a whole and pick their way through it, making informed decisions. But it will also be a useful tool for end users who are commissioning DNA-based monitoring work, who are likely to then end up having to evaluate proposals that may vary quite substantially in the proposed methods. So this gives them a sort of a reference point to be able to go through and work out what those different options are and which ones might be best suited to the particular context in which they're going to be applying this monitoring. So to summarise, we've seen a really huge shift over the last 4 years, and DNA-based methods are being rapidly adopted across Europe and beyond, even though it's going to take some time to integrate into the WFD. And we actually already have a pretty good level of consensus around the main principles of field and lab methods, even if the details vary. Having said that, there's no one silver bullet protocol. And there are loads of inherent trade-offs and still a lot of areas where further research will bring more improvements. So our challenge at the moment, I think, is to standardise methods so that they can gain the maturity they need for widespread adoption, while also encouraging continued development and innovation. So I just want to finish by saying a huge thank you to everybody who's contributed their time, expertise and support and good humour to Working Group 3 over the last few years. I know a lot of people have put in a huge amount of effort, often in their spare time, often at weekends, often late at night, to make a success of the workshops and the training schools and the meetings and to produce all the resources that we've created. I think we've made a really significant collective contribution to the growing up of this field, and I personally have had a lot of fun along the way and loved making new friends all over Europe. So thank you very much for listening. Thanks for being part of Working Group 3 and enjoy the rest of the presentations. Thank you.